So you've looked at the problem and you need to supply the missing factor. 10 times what equals 10? 10 times 1 equals 10. So let's say this time, though, we are going to say now here's the trick, though. You're only, in order to solve this problem, you're only allowed to use one factor, and that's 10. You can use 10 as many times as you want until you get to 1,000, but you can only use the factor 10. So take a moment, write the problem on your desk, discuss with your neighbor what you did to get to the answer 1,000 by using only the factor 10. Okay, we're going to look at this problem. We can only multiply by 10, and we want to get from 10 to 1,000. So if I just started with a 1 right here, and every time I move over, it's times 10, right? Times 10. Where do you think I'm going to stop? What place will I be stopping in if I want to find out how many times I have to multiply to get to 1,000? You think I'm going to have to stop at 3 times? Give me a thumbs up if you think I'm going to have to stop at 3. If you don't, show me another number. Okay, let's take a look. So I do times 10. Will my 1 now be at the thousands place? Have I just moved it over? Let's see. So how many times do I have to multiply 10? 3 times. How would I write that as a number sentence? How would I show that?
You would do 10 times 3 equals 1,000.
So I could try 10 times 3. But what's 10 times 3 equal? 30. Would that work? Nope. What else might work? Well, you can only use the number 10, though. 10 times 30? Well, let's stick with the number 10. How could I do that? So I could do 10 times 10 equals 1,000. Should we try it out? What's 10 times 10? 10 plus 10 is 20. 10 times 10 is 100. And I have one more 10 to go, right? So let's multiply by the next 10. 100 times 10. Remember the trick? You multiply the front numbers and then you add the zeros. So 1 times 1 is 1. How many zeros do I have? 3. So I just used the number 10 3 times. Did I get to 1,000? Was it the same? Yes, it was. So thinking about the previous problem, the problem we just did, I want you to try to get to 10,000 only using the factors 10. And you can use the place value chart that I have on the board. So you want to get from 10 to 10,000. by only multiplying by 10. How many times did you multiply the number 10 to get to 10,000? 4 times? Give me a thumbs up if you multiplied the number 10 4 times. If you came up with something different, show me. So in order to get from here to here, we had to go 4 times, right? So our problem would look like this. I don't know about you, but that starts to get confusing, doesn't it? Especially if you start to get to millions and billions. 10 times 10 times 10 times 10. That is too much. So they were nice to us and they came up with a method. So make sure you pay close attention right now so that you get this. How many times did we have to multiply 10 to get to 10,000? 4 times. How many zeros are in 10,000?
4.
Do you notice a little pattern there? So if you multiply 10 times 10 times 10 times 10 4 times, your answer will have 4 zeros. Because if you look up here, how many zeros do we have? 1, 2, 3, 4. Okay, thinking about that pattern. Let's look at the number 1 million. I see a lot of writing on desks right now. We probably want to stop so that we can learn the new information. So there's 1 million. That's what 1 million looks like. How many zeros does 1 million have in it? 6. So how many times do you think you have to multiply by 10 to get to a million? 6 times. So that would look like 10 times 10 times 10 and so on, you know, where you fill the whole page. So looking at the bottom of your sheet, it says engage NY. And right next to it right now, it should say 1A39 because that's the page we're working on. We're working on problem set question number 1. It says write the following in exponential form. Well, exponential form is a way to help you deal with not having to do this. Exponential form keeps you from having this mess. Exponential form means that I count how many tens I had to do. How many tens did I have to do?
6.
I had to do 6 to get to a million. So this is really cool. You ready? We're going to start talking about this thing called powers. 10 to the power of, how many times did I have to multiply? 6. 10 to the power of 6 equals How many zeros are in a million? 6. So I know that 10 to the power of 6 is a million because a million has 6 zeros. So look at question number 1, A. 10,000 10,000 equals 10 to the power of 3? 4? Okay. Thumbs up if you think 3, thumbs down if you think 4. Okay. Remember, it's based on how many zeros are in the number. So, how many zeros do we have? 4. So, what number is going to go behind my 10? 4. But are you going to write it like that? Does 10,000 equal 104? How will you write it?
You have to write the 4 small since you have to write the 4 small since if you do it too big, like the size of the 10, it will look like 104.
Exactly. So this is where you need to use your best handwriting because you're going to have a raised number and it's going to go up above. So the answer to 1A is 10 to the power of 4. So in B, we have the number 1,000. How many zeros are in 1,000? 3. So I just do this. Okay, so we know we have a 3, so it's going to be to the power of 3. And then what number am I missing that helps me get to 1,000? 10. So we would have 10 to the power of 3. In C, we have 10 times 'Now they say on here to write the following in exponential form. So are you going to write that 10 times 10 equals 100? Is that what they're wanting you to do? No, they're wanting you to do it in exponential form. So what would that equal? 10 times 10 equals?
100.
No, I don't want 100. Think about exponents. Try again. 10 to what power? How many times are we multiplying 10? 10 to the power of? No. No. This is a tricky one.
What's the answer is 100. How would you write 100 exponentially?
10 to the power of 2.
10 to the power of 2. Because I have multiplied 10 2 times, right? Okay, D was a little bit of a challenge for some of us. Because I think they're trying to trick you. Have we said anything today with 100 to the power of anything? No. But we have talked about how many zeros does 100 have in it? 2. So what would that be? 10 to the power of 2. So 100 equals 10 to the power of 2. Is this the same number over here? That would be 10 to the power of 2 because I have 2 zeros. So what would my answer be? What do you think the answer would be? It's a little tricky, this question. 10 to the power of 4. Now, if you wanted to multiply it out, you could say 100 times 100. And we know that we multiply the front two numbers, right? And then we add however many zeros are there. How many zeros do we have total in both those numbers? How many zeros total do we have?
4.
We have 4 total zeros. Would that also equal 10 to the power 4? So you can do it either way. You can divide out the number and say 10 to the power of 2 plus 10 to the power of 2, or you could say, well, I know that we just add all the zeros to the front number, and I end up with 4 zeros. Okay, problem 2. Start something different. We're no longer just dealing with ones. Now we're dealing with actual numbers. So let's look at the first one, 2a. What have we been saying this whole time? What this number right here represents? What does it represent?
The number of zeros in the first number.
Yeah, the number of zeros, right? So if I have something like that, what do you think my answer might be? How do you think I'm going to solve that problem?
9 times 9 times. You just have the 3 zeros. So 9 times.
Okay, so she thinks maybe you take 9 times the 10 with 3 zeros behind it. Any other ideas?
9 times 30.
Maybe 9 times 3?
9 and the 3 on top of that. How many zeros are there?
Okay, so he's saying that you have 9 because 9 times 1 is 9, and then you add 3 zeros. Any other ideas how that might work?
That's it. Remember that 9 times 10 and then add 3 zeros to the answer.
Okay.
That you keep the 3 and then you put 3 zeros after the 10. And then you do 9 times that number.
Okay.
And you change the 10, since it has 10 to the power of 3, you change it to 30. And then I do 9 times 3 to 9 zeros.
Okay. Well, guess what? You guys have already been doing this today. You've already been doing this. Because if I said, I want what would my first number be? Remember, you take the whole number, so 1 times 1 is 1. And how many zeros is it going to have in the answer? 3? Whoops, that wasn't right. So let's look back up at our top problem. What would 9 times 1 be? And yes, someone did say the correct way to do it a little bit ago.
9,000.
So when you have a number times 10 to the power of 3, what do you think you're going to do? What are you going to do with that problem? Yes. Or you can just look at it and say, oh, any number times 1 is itself, right? So if I were looking at this, I would just say, okay, I have 9, and I'm putting 3 zeros behind it. So 9 times 10 to the power of 3 is 9,000. Try the next one and check your neighbor and see if you guys both end up with the same answer once you're done. Okay, on this problem, what's my main number that I'm going to write down? Okay, so in order to get there, what number did you start with?
39 times 1.
Okay, so you did 39. And then how'd you know how many zeros to put behind it?
By the 4 at the top of the 10.
Okay, so you look at,
4 zeros after the 39.
perfect. You look at the number, what is this number called? What is this number called? How about everybody? This is a power of 10, but we call it an exponent. Remember, these are the factors right here. And this little number right here, what do we call it? Exponent. One more time. Exponent. There we go. That sounded more like it. My exponent says 4. I'm going to have, and I'm not going to worry about putting the commas in my number until I'm done writing the whole number. So every 3 spaces over, you have a thing called a period where you add a comma. The next one, we're going to probably get a little trickier. Would you be surprised if we made it through and it didn't get tricky? I would be surprised, yeah. Okay, so we have the number 7,200. We're on letter C. 7,200 divided by when you say the exponents, I wouldn't say 7,200 divided by 10 to the 2 power. Think about it the way you say grades in school. If I were talking about this top grade, how would I say that? 10 to the, you could say 10 to the power of 3, or you could say 10 to the, how would you say that grade level in school? When you were in that grade, what grade were you in? 3rd. If I said the next one, I could say 10 to the power of 4, or I could sound a little more educated and say 10 to the 4th power. This is 10 to the 2nd. So I have 7,200, but this time I'm doing the opposite. I'm not adding, I am subtracting. Now, I could, go ahead and just have you do what you would naturally think you would do and just erase zeros. But what happens when you have no zeros to erase? Then you have a problem. So instead of starting out by teaching you how to erase zeros, I'm going to just show you the method so that you don't have 2 things going in your brain at once. We have the number 7,200. We have talked this week about something that's imaginary, kind of like, the equator around the Earth. You know that equator? It's there, but you don't see it, right? The air you breathe, it's there, but you don't see it. There is something at the end of every number that's always there, but you don't see it. I wonder what it is. A decimal. A decimal is always at the end of every number, but you never see it. Unless you have numbers that follow, okay? So there's always an imaginary decimal behind every number. So my suggestion is anytime you have a division with the powers of 10, what should you automatically just put behind the number? Automatically, without even thinking, what should you automatically put? Everybody. Decimal. Okay, a decimal. So I'm going to go in here and I'm going to put my decimal right there. How many numbers to the left will I be moving that decimal, do you think? Show me with your fingers. How many numbers to the left will I be moving that decimal? Okay, everybody's saying 2 because this is to the second power, right? So I'm going to take this decimal and I'm going to go through the first number and through the second number. Look at my problem. How many numbers are now above my upside down arches? I have 2 numbers above my upside down arches, right? Does that match 10 to the power of 2 or 10 to the second power? Yes. So the answer for 7,200 divided by 10 to the second power is, what do you think? 72. Do you need to just add zeros after the decimal? I mean, you can add as many zeros as you want, but the number is 72. Okay, with your partner, your neighbor, I want you to try the next problem. That's a pretty big number. Glad we're dividing it out, not multiplying it. Does this seem easier today than it has? I think you guys are getting into the So if when you were talking to your partner, you guys decided that you would create an imaginary decimal. Now, a lot of times I see people trying to write on the number that's already there for them. It makes your life a lot easier if you just write the number somewhere else. So you can write it larger. My other suggestion would be to not put the commas. Because if you put the commas in, that gets confusing when you start moving decimals. So at this point, I would even say don't even put the commas in. Because will that number still be 7,200,000 when we're done with it? Will it be? Because we're dividing it, right? And when you divide, the number becomes smaller. Okay, everybody, let's see if we can do this. Where's my decimal? Everybody. At the end. Where's my decimal?
At the end.
Can I see my decimal?
No.
Can I make a decimal?
Yes.
Where does my decimal go?
At the end.
Okay, at the end. What direction does my decimal move when I divide? Everybody.
To the left.
To the left. Isn't that a song or something? To the left, to the left. Yeah. Okay. This says 10 to the power of 3. We are dividing 10 to the power of 3. How many times is that decimal going to move? 3 times. How many arches am I going to make?
3.
And how many numbers are in each arch? How many numbers are in each arch? 3. No? Sorry, each arch. We're going to have 3 arches, yes. And how many numbers are in each arch? 1. So we're going to make 3 arches. Maybe 1, 2, 3. What is my answer to 7,200,000 divided by 10 to the 3rd power? 7,200. If you and your partner got that, give yourselves a pat on the back for doing a good job of listening today. If your partner had to guide you through most of it, make sure you pay a little closer attention to the next problem so that you do a good job. Just a reminder that your homework pages are exactly like these. So if you can do these, then you can do the homework, right? Here they go. They're mixing it up again. Can anyone read the number for me on E? How do you read that number? It's not 4.025. So if your hand is up and you're ready to say 4.025, nope, that's not the answer. 4 and 25 thousandths. See, correct? Yes, he is correct. So we have a problem here. Times 10 to the 3rd power. Well, if the decimal is at the end of the number, we could add zeros, right? But now we have a decimal that we're moving around. So if the decimal moves to the left when you divide, what direction do you think you're going to move the decimal when you multiply? To the right. Is that kind of what you did on this problem up here? Let's think about that. If we have 9, the number 9, and we put the imaginary decimal in here, right there, could we have made 3 arches? Because it's 10 to the power of 3 or 10 to the 3rd power. 1, 2, 3. And put our imaginary decimal over here. So whether or not you add zeros is based on the decimal. It all revolves around the decimal. So let's think about this problem. Work that problem out with your partner. 4 and 25 thousandths times 10 to the power of 3. Maybe. Oh, there we go. 4 and 25 thousandths times 10 to the power of 3 equals 4,025. Because when you multiply by 10, you're going to take the decimal and move it 3 times. And it becomes 4,025. The beauty of this method that you're learning is it keeps you from having to do this. Okay, that right there gives me a headache to look at. So this is good because in most cases, if you would sit down to see a problem that said 425 thousandths times 10 times 10 times 10, you'd be like, oh my goodness, this is too much, I can't do this. But just a minute ago, I heard some people saying, oh, I got it. And I had just like written it on the board. So it's easy, isn't it? It's a quick way to solve problems as long as you just pay attention while I'm teaching it, and you'll do a good job. And the next problem is F. Okay, remember the best thing you can do for yourself is to take the time and write the number off to the side. How many places am I going to move the decimal? Everybody. What direction will I be moving my decimal? To the right. So I'm going to take that lovely decimal. I'm going to go 1 arch, 2 arch. Can I continue to make arches? Because I need 4, right? 3, 4. So I have 4 arches, but I have empty arches. And if I have an empty arch, it's not really a number. So what do I need to do with my empty arches? Put a 0 above each one, exactly. So 40 and 25 hundredths times 10 to the 4th power is then you go back and you count 1, 2, 3, put your comma, 1, 2, 3, and we're good. 402,500. Make sure you're writing all this down. G, 725 divided by 10 to the 3rd. And that didn't write the whole sign. There we go. Okay, everybody, where's the decimal? Everybody. Oh my goodness, that was not in unison. Everybody, 1, 2, 3. I'm dividing. What direction does the decimal go? Everybody. Left. Everybody. How many times does the decimal move? 3. So I'm going to write my number. 725. I'm going to add the decimal to the end. And I'm going to go 3 places to the left. 1, 2, 3. Raise your hand if you can read that number to me. Decimals are hard. I'm going to show you a trick that I use, so pay attention, okay? You ready? Watch this. Here's my trick. Cover the decimal. Play like it's not there. So if I cover the decimal, I'd have that number, right? So how would you read that number, everybody? 725. 725. What place is the 5 in? Thousands. So everybody, how would I say that?
725,000.
Good job. H. I think we're going to get through this. H. How many places am I going to move my decimal? Everybody. Which direction am I going to move my decimal? Everybody. Left. Rewrite your number. Move it to the left. 2 places. I'm going to have 1 arch. 2 arch. Put my decimal. Can I leave an empty arch? No. What goes in the empty arch? Everybody. 0. So remember my trick to read the numbers, the decimals? Cover the decimal. What does that leave me with? What number is that? Okay, so if I cover the decimal, I would say 72, and the place it's in is the thousandths. So, everybody, how would I read that number?
70,000.
We will not have time to get to the word problems. So for your homework tonight, you will be doing all of the problems except the word problems. There is a whole method to explaining, and we'll take a class period at some point to just talk about how to explain. I want to go through number 5 quickly with you before we have to stop. So everybody freeze and pay attention. Number 5. Okay. Shh. Freeze. Hands up. Pause. Okay. You can put your hands back down as long as it's not touching anything right now. Number 5. I'm on 1A40. Says complete the patterns. Well, at first it starts with, and then it goes to what's changing in each of those numbers. What's changing?
They're going up 1 spot, like that's in the hundreds, and then that's in the tens, and then
Okay, so what is it that's moving?
it's the decimal that's moving.
Exactly, the decimal's moving. Perfect. And it's moving by how many places each time? The decimal's moving, let's see. How do I make this number look like this? You move the decimal over 1 place to the right. So if I go 1 place to the right on this number, what do I end up with? 3. And then they say the next number is 30, and then we have a blank. Well, if I go 1 place to the right on this, what does that give me? If I have 30, and I take the decimal 1 place to the right, what does that give me? 300. And my suggestion when you're doing patterns like this is not do it the way I just did it, but to start like over here with it, because now we're on 300 and we still need to go another place, right? So what will our next number be? 3,000. So make sure you've done that on A. Okay, we're fighting the clock here. One more. We can do it, people. We can do it. Okay, B. 6,500,000. And then it goes to 65,000. Well, how did they get 65,000? What did they have to do? Here's what I would do if I were you. I would get rid of these commas, because we know the number just got smaller, right? And I would be prepared to use an eraser. Or if you have a dry erase board at home that you could use, that would be great too. And I want to make this, say, 65,000. How many zeros are in 65,000?
5.
Okay, 5, well, there's 5 in 6,500,000. And then how many are in 65,000? 3. So we just went from having 5 zeros to 3 zeros. So how many places are we moving the decimal each time? 2. So we're going to take this and move it 1, 2 to get 65,000, right? Do we need to keep those zeros? No, so I'm going to just erase them to get them out of there because that gets confusing. So the next one we're on, we're going 2 places to the left, right? 1, 2. What does that leave me with? 650. So that's your answer to your next box. And if I want to go 2 places over again on 650, boom, boom, what does that leave me with?
5/10.
Okay, 6 and 5/10. And then if I want to take that decimal and move it 2 places again, what would that leave me with?
It would leave me with decimal point 0. Decimal point 65,000.
That's right, 65.